Master's of Science degree at Columbia University, his Master's of Science in Civil Engineering at Stanford University, a second Master's of Science in Engineering Economic Systems at Stanford University, and a PhD in Civil Engineering at Stanford University. So he's really a cardinal gone Longhorn. Prior to joining the University of Texas, Bill led the product development and planning efforts at Collaborative Structures, which was a Boston-based internet startup firm focusing on construction industry. And Bill's technical interests are in production systems and computer-integrated construction. I will say, and this is unscripted, that since I've been department chair, Bill is one of the faculty members in our department that I can actually count on when the department needs something to happen or get done that takes time. And Bill has volunteered several times and saved my butt as department chair and helped the department immensely by going above and beyond the call of duty. And so Bill is a great, great team player in the department. And so I think I'll introduce him as Mr. Team Player, and I think you'll be very, very impressed with the other stuff that he does. Bill?
Thank you, Rich. I appreciate the introduction, and I should say that we also want to thank Rich for the work he's done as a chair, as someone who has done a lot of service. I know it's a lot of thankless tasks, and Rich has got countless hours doing things. I know he told me a week ago that he was spending 10 hours on a Sunday to work on ABET preparation and things like that. So thank you, Rich, for all you do for the department. It's where technology works here. It's my pleasure to speak to you today about productivity and profitability in the industry. And these are, I think, our twin challenges. And let me just ask a question, first of all. How many of you wish your firms were more profitable? Not all of you? Okay. And then, so I know you all a little bit better. How many folks in the room are owner types, real estate developers, owners, major owners? You? How many are engineers? Number? And how many contractors do we have in the room? All right, a few. Maybe I should give a shout out here to Mr. Hahn, who's been a good friend of the program, one of our graduates of the program. And I was going to say, when the gentleman from the Fed was here, as an Aggie, I was going to say, well, the Longhorns actually built this building, so we should be grateful it's still standing. No, well, not because of Longhorn, but grateful because that's was good for the Aggies who built this. Let's talk about the projects industry. And this is from some friends of mine from Fiatech, which are technology folks in construction. And this is from Reg Hunter, who is a rocket scientist by training. And he says, true, the capital project industry is not rocket science. It's much more difficult. We have more degrees of freedom. We have more that goes on. It's a wonder that we do as well as we do sometimes. And it's a great, challenging, wonderful industry with lots of technology. And it's all about people, too. And that's really why I'm here and why I'm doing what I do, is I love to put the two together, is the people side of the business and the technical side of the business. At the same time, it's time for a challenge. It's time for us to get better. And so I want to speak to you today, and like all professors, I probably have too much to say, but I want to talk a little bit about where we are, a little bit of introductions, and also to give a little history for myself, because I'm at, I think, a watershed moment in my career of changing what I have done into directions in the future that's going to drive us to the next level. I'm going to come back and talk about the challenge and where we are with productivity and profitability, and offer a few partial solutions. And those partial solutions are some work that Sarah over here, Sarah, was one of the first students on, did some stuff for advanced work packaging. Sarah and Corey sitting behind her are married, and I have the enviable position to say they actually met in a project in my class. So, and they are wonderful, wonderful people. I'm so happy that they're graduates in one of those. I'll tell you a little bit about some solutions, then tell you a bit about the future. Because when I say solutions, they're partial solutions. They get us part of the way, but we need to go more. And I want to talk in the future about where we're going with research, and also kind of come back and circle what that means for education for our students. And so just a little bit of background, so this is a bit of a watershed moment in my career. So my journey started as an undergraduate in New York looking at 3D modeling before it was called BIM and trade coordination. Learned a bit about that, and I went to California for 5 years, and I was the first supply chain guy in construction and looked at production and economic systems and supply chains. Then I went to Boston for 3 years and did not become an internet millionaire, but I learned a lot by trying to sell software to our industry and develop for our industry, looking at implementation, and then came back to academia. I said, what do I care about? Well, I care about construction, and where can I have the most difference? Well, I think that's because, or as a faculty member. So I spent 5 years at the University of Florida, so I was a Gator. And then since 2004, for forever, I'm at the University of Texas and love being a Longhorn and all the tradition and everything that is Texas. And I'm very happy to be a part of it. So that's my journey, and a little bit of background of sort of where I come from as a systems implementer, as a modeler, as someone who's worked on trying to make construction more productive from a holistic perspective for a very long time. Just a little shout out to my colleagues in construction engineering and project management at UT, John Borcherding, Carlos Caldas, our newest colleague, Casey Faust, Fernanda Leche, and Jim O'Connor. I've had the privilege of working with them and learned so much from them as well. And for those of you who know Fernanda, her biggest accomplishment in the last year was not getting tenure. She just gave birth last week to her first child, Julia. She's doing very well. I just saw mother and baby yesterday for the first time. I'll give a little bit about the Construction Industry Institute. CII is over 30 years old. It was founded by Richard Tucker, who's an emeritus faculty in our group, and has about 130 member companies, and it's a very strong organization, and it's a pay-to-play organization. They want about 40,000 a year in dues, and they want a lot of your time too. And so if you're going to participate in CII, it's probably $100,000 a year in kind and travel and the actual member dues. But by doing that, they sponsor research teams, and we go out there and we work on industry teams. And Sarah was one for 2 years, and she got to go, and then she was snapped up by Exxon to go work for them. We're not only training the next generation, we're really helping the industry get better by collaborating directly with industry. And so a lot of what I want to tell you about is really reflective of the experience for the last several years, 10, 12 years at UT, working closely with industry. Now, a shout out for CII. One of its great accomplishments is the reduction of the incident rates for safety in construction. And it has, over the 30 or so years prior to this chart, been a leader in safety. And you can see that in the bottom. Of course, less is better in the safety chart. And when I look at this chart, this is not just numbers on a page. This is thousands of people who have gone home every day safely, not being injured or killed. And not just that CI is always proud to have a line, pat on the back for the bottom line as leads the industry, but the industry itself has gotten better. We've been a significant force in making the industry a safer place. And so let me ask you all, how many of you in your companies have a significant investment in safety review, safety operations? Good number of you all, as I would expect to say. And as CII representative and UT rep, we've been very much part of that, and we're very proud to have helped that. And that's probably one of our most singular achievement. That said, it's time for us to move on to the next achievement we need to work on, is go back and work on productivity and profitability. It's no secret that construction firms and really engineers are not particularly happy with the profitability. This is some numbers from SageWorks, which is a private industry firm, so these are non-listed companies, but I don't think they're very different from those that are listed. And we have a problem. We're not as profitable as an industry as perhaps many other firms are. Now, we're also not as productive, and this was a short video I was going to show you. We're having some technology differences. 1963, the Jetsons. I'm sure we've all seen the Jetsons here. episode 22, Private Property, the first season, has been building and building, and then they're coming up there and I'll play the video for a second here, while they're jackhammering and the whole building is shaking, and they take a building and they basically just put a big thing on top and they just pull the building up. And Mr. Spacely is talking to George Jetson, and Mr. Spacely says to George, "Wow, that's really fast now. It used to take him a whole week when I was growing up." And so that's a 1963 cartoon, but that was in 1963, that was the future of what they thought construction was. Unfortunately, we have reality. And this is a chart that starts in 1964 in small print, and the orange line, I did not put the color, the orange line is the construction line. And it shows that from 64 till this chart goes up to 2006, but it hasn't gotten better. We've actually had negative productivity growth in the industry. And that's compared to the blue line on top is the non-farm productivity index, which would be including construction. So basically all manufacturing, construction, other businesses apart from agricultural, has more than doubled since 1964 in terms of aggregate productivity. Now there are lots of people that have picked at this graph a little bit and said, well, you know, we've done better in this, and we've done better in that. And there's some truth in those critiques, but at the same time, the average and the aggregate is we have not gotten very better. And this is a big challenge for us. And so it's not just the US data. This is from Barry LePatner, who's a big New York construction lawyer, and he gave a talk at the CI conference last year about it. He was pushing his new book, Broken Buildings, Busted Budgets, and he put together global data that shows much the same thing from 1995 till basically today, a little bit later earlier starting point. Construction has stayed flat or decreased versus almost doubling in non-construction industries. We see this in how construction people spend their time. This is data from COA, where I'm heading up to tonight actually for the oil sands up in Edmonton. And on the left and on the right is data from CII data that basically shows different pictures of the same graph. We spend about 30 or 40% of our day in the field, the crews being actually productive in tool time. And the rest of it is other time, and that says there's a lot of room for improvement. We see it in project failures. Ed Marrow from IPA, IPA, for those of you in the petrochemical industry probably know well, is a very well-established private consulting and benchmarking outfit. And he's written a book on industrial mega projects that talks about 65% of their projects, over $2 billion, have failed on multiple measures, either 25% over cost, 25% schedule, significant underperformance of the asset once it's deployed. And the sad truth is, we're not much better at smaller projects as an industry. We all know our exceptions, but we could do better. And so IPA also has the same graph, or same data set is used to show, as adjusted for inflation, the asset price per barrel has increased by a factor of 4 from 1996 to 2014. And so that is many reasons for that. It's become harder in the oil price throughout. You're going after harder barrels, but frankly, a lot of that's due to poor productivity. We're not that very good at it. And this is CII data from their benchmarking that basically says, look at the scatter plot here. We're not very good at predictability. Sometimes we're ahead of schedule, sometimes we're behind. Sometimes we're under budget, often we're over. And it's one of the worst things you can do from a capital perspective to not have that targeted and be right at the center of the graph. Ideally, you'd like to be predictable for cost and schedule. Of course, it's better to come in under budget and under schedule, but then you've stranded capital that could have been deployed somewhere else. And so from a CFO perspective, this is not a pretty graph either. And so I've lived with this graph for as long as I've been a professional in this industry, and it's been there, and it keeps getting growing and growing and growing. The tails get wider and wider apart. And I would say to you at this point, this is the great shame of our industry. There's no reason we cannot get better. And it's linked in part to low profitability, and you can say, is the tail wag the dog there? What comes first? Is it the inability to be high profitability limits the ability to invest in innovation, or is it the lack of innovation that drives up more competition and so on? It's unclear, but it's obviously part of the problem. It's not the whole problem. There's lots of other problems we have in our industry, the regulatory environment and so on. But it's in part profitability and productivity are linked. And I would say to you this, it's not a construction problem, or it's not solely a construction problem. If I talk to my colleagues and that are doing design, they would say, okay, that's a construction problem, Bill, you fixed that, you're working on that, right? And I said, yeah, we are, but it's not us alone. And that one thing we need to do is it's a problem for owners, it's a problem for the engineers, it's a problem for everybody. And if we don't collectively start to address this, that graph is not going to get any better. So a lot of you, yeah.
Has there been a study done on on-time completion for municipal contracts or government contracts that have incentive pay for the contractor?
There probably has, but I do not know of the specifics of it.
Houston has had good results with incentive pay.
I can imagine so. There are lots of opportunities to do better. Nonetheless, we're not doing better as an average. So there's always the exception, but the exception is not the rule, I think I would say to that. We can come back to that and have that discussion again. And I would say though, but to get back to it, it's not a construction problem, it's everybody's problem. How many of you in this room, a lot of you said you had significant investments in safety. How many of you have a similar investment in productivity improvement that would rival your safety programs? Maybe. Close, some investments. You guys?
Definitely with respect to internal resources. Profitability or productivity, efficiency, capital use is a huge focus. But with external companies we contract with, not so much.
It's a tough one. There's a lot of investment in status quo. And a friend of mine, Tracy Koss from Marathon Petroleum, who's a senior manager in the projects division there, says it may be time for owners to start thinking about productivity as we did for safety 30 years ago to drive those curves better. Otherwise, we're not sure we can get better collectively.
I think there's a business model problem with both the owner side and the contractor side that perhaps may be the genesis of some of this. In that you want the lowest bid,
Yep.
and the contractors had to fight to develop one to get the award. And there's sacrifices that have to be made. And their business model doesn't provide enough profit to train people, keep training people around. And the owner's business model says, let's get the lowest responsible bidder. Moving to a different model of reimbursable costs gives the owner an opportunity to actually own productivity, and that the owner's taking on planning in many elements. But that's not a business contracting form that many owners want to play with, because there's the narcotic of the apparent low cost that stays in your bloodstream.
We have a very short-term mentality as an industry. It's this project, and we're not going to invest for the future, and it drives down the profitability. It hurts the ability of the contractor sitting next to you to invest in his people, and that's seen in our workforce. We're not investing in our workforce. The workforce is aging. It's getting lower skilled people coming in. Our ability to train them has gone down. We have a lot of investment in the current system. One of my early mentors told me many, many years ago now, he was an ex-Corps of Engineer Colonel, and he said, well, A, we wrote a paper, the case for cost plus contracting, which is exactly your point. And B, he said, this industry is not going to change as long as engineers keep selling their services by the hour and not by the value provided. And so that's a tough one. Oh boy, I got a whole list of stuff over here.
No, actually, when you take and compound not only the low productivity, but the high labor rates,
Yeah.
then we really have a problem.
Yeah.
Especially in my industry, like you mentioned, the IDA. I mean, I live with those guys in every project or through all the stages of authorization, and I can tell you, they're great, they have a lot of data, but the Gulf area, from Louisiana all the way to Corpus Christi, it's been a very high market in recent years. And that actually has provided us a huge challenge for us, because obviously our data and how we actually estimated projects is not aligned with the benchmarking from IPA, and therefore we always kind of show on the high side being projects too expensive, and really that in some instances it kills the projects. So productivity is in the mind of everybody, and the only way we take that is by factoring lower productivity, putting more money, adjusting a contingency, but it's still.
And it becomes a self-fulfilling prophecy. I see I've scratched an itch here, so.
So I agree with you. This is a problem that should be able to be solved. So what are the impediments that keep this from being solved?
So I tell my students I don't have all the answers. I have some of the answers, and I can give you a pretty good set of the problems. I can tell you a little bit about where some of the successes have been that I participated in, and some of the challenges that remain, and how we can get somewhat better, and then where I think we need to go. Corey, you had a quick.
Yeah, I know. At my company, you talk to a lot of guys that've been around 30, 40 years. We used to invest in a lot of kind of after-hours training for pipe fitters and welders and different craft, and then that kind of went away 20 or 30 years ago. As there's kind of, I guess there was less loyalty between the craft workers and the company. It used to be that they kind of traveled from brown and root job to brown and root job. And now it's kind of like, well, at the end of their job, they're kind of released, and we may rehire them on the next job, we may not. And so the fear is, well, if we train these guys, they may go somewhere else. So we're kind of investing in someone's it's not going to be working for us.
You do that, Bechtel does that, Floor does that, and it's a race to the bottom, and we see that. We have lots of structural problems, and actually as a research team I'm working on right now is the role of the foreman in productivity, and so Rich coming back here next year, and I can tell you that's coming out. But let me move on a little bit so I can get to some discussion here, and I wanted to come back to, we talk about construction being poor productivity, but it's not purely a construction problem. Again, this is IPA data that in the major petrochemical and power industries talks about the field productivity problems are not a field problem. It's an outgrowth of poor engineering deliverables on fast-track projects. So since 2008, according to their data, and their data is pretty solid for the projects they benchmark. If you had an IPA people, they do a good job at getting the full data within reason. So the engineering quality has declined, speeds decline, adequacies decline. There's engineering slip. Slip in engineering, according to them, is now approaching 40% on large and small projects. And this is from a 2015 talk. And they also can say it's not just a mega project problem, it's an every project problem. And you can argue we got too busy and we had too many engineers doing too much, and now we're laying them off because we don't have many projects in the pipeline. In any case, the shortage is we're not doing it, but at the same time we want projects to be more fast-tracked. In fact, I had a project a year ago called flash-track projects, which is the worst idea I've ever heard. So insanely fast-track projects, so that basically you'll start digging before you've done engineering. I don't know, it works for China, so maybe we should just start that. It's an every project. It's an every project problem, and as we keep getting, because the cost of projects has gone up, that lack of productivity, we're getting more and more business pressure to compress time, which makes the system, which is already poor, under more stress and does not respond well, and that leads to slippages, errors, poor performing assets, and so on. And that's kind of, we're in that downward spiral, and we need some kind of a radical change to get better. And that's not Bill as a construction person. Part of my job, and I'll end on that note, but I'll preview it, is my job is to convince Dr. Corso, who's in classes, he needs to think about this too, and he's telling engineers what they need to be doing and so on, to start to embrace the holistic responsibility for moving the projects forward. And so this is another view of the downward spiral of engineering. So if you're on a fast-track project, if you have incomplete scope and early loading, or front-end loading in your engineering, that just kind of gets things going with poor engineering quality deliverables, which leads to late materials and late fabrication because 50% of the project cost is off-site, to a premature start because you want the contractor to get going, leads to poor labor productivity, and those numbers keep getting bigger and bigger, right? And so we see that, and it becomes a self-fulfilling prophecy, and then, hey, we get that in our estimating database, and now that's the new norm. We don't get better, we just expect it, we just price the projects that way. So what are some partial solutions? It was 7 years ago with Sarah, we started a project with CII to look at advanced work packaging, which was looking at some of the stuff that was going on in a few Gulf Coast projects and a few oil sands projects. The oil sands, nothing like a real crisis to drive them to start to get better, to think about how to improve work packaging. And so based on that, there's been 6 years of work on defining a new industry best practice as nominated by CII on advanced work packaging. And advanced work packaging is kind of a back to basics, tie your shoes idea, which says plan well, get everybody involved in the planning early on, have discipline how you do that, which is through we call construction work packages and engineering work packages, and carry that planning through to execution so you can install well in the field through construction, commissioning, and startup. And it's basically work planning emphasizes construction requirements. And if I explain it in those terms, not one of you could argue against it. You might argue it's hard, but you couldn't say it's a bad idea. But it's reinforcing the discipline as an industry we've lost because we want to get going fast, we haven't done the planning very well, and that snowballs from there. So what are some of the benefits? The companies that are doing advanced work packaging well are finding foremen are spending more time in the field. We've seen safety, productivity, quality improve. We've seen better resource utilization. We've seen better alignment. And we've seen 25% and even better productivity improvements, and with that, a 4 to 10% decrease in total installed costs. And we've got that from multiple case studies. In the last 2 years of what I did for CI was to validate that so CI could declare it as a best practice. So what's really new about this? Like I said, it's really about tying your shoes well, but it's the extension of front-end planning across the project life cycle, so you don't just put it back on the shelf. You say, how are we going to do this? And we're going to keep that project going alive through the life so that we can be successful at the work phase. And it's a very focused effort to overcome the problems of fragmentation that divide our industry. So we need to get people out of our silos. We put them in the room up front so that we have an execution plan that makes sense, and then we carry that through. And there's really two new ideas there as part of that kind of common sense approach. One is a redefinition of work packages, particularly an engineering work package, which is the design part of a larger construction work package. That engineering work package is no longer how the engineer manages his work, but is an agreed deliverable to the field. And so you organize your work early on as a set of engineering work packages that can be delivered by the engineering team. They agree to in interactive planning sessions to deliver to a construction need date. And that's a really subtle change because engineers don't normally work that way. They work by system and they get it done. They hit IFC drawings when they're ready or when it's done, and then if it's out, they've got holes on the drawings. So this is getting the engineers in the room with the construction early on and agreeing to a plan that's workable. Not construction-driven engineering, but a workable plan everybody can subscribe to. And the other new thing about this is we're adding a role to the field. And ideally, it should start earlier than field work, called a work phase planner, who is there to take all the information and planning that a general foreman used to do and help that general foreman and foreman bring that to the field so the foreman can go out in the field and be more productive when they go. What does that mean? Well, if you can increase 25% of the time the workforce is working, so rather than having just 37% of the time in the field being productive to be more like 46%, that gets you a 25% productivity improvement. And if your field costs are 40% of your project, 25% times 40%, that's a 10% decrease in total installed cost. That pays for a lot of the extra planning. And so that's what we're seeing on projects. So we've done a bunch of case studies about that. And I want to say the most important thing about these case studies is they're small projects of under 5 million all the way up to mega projects. A quarter of them are small projects. It's not just a big project thing. And I'll tell you a little story about two of them. One of them, this was an $8 million project, North Slope in Alaska. Good apples to apples comparison. The same owner, same contractor, just different crews in the field. On one project, the crews were traditional. On the other project, they used advanced work practices. So, small project, project without AWP did okay. The project with AWP came in $73,000 below budget, 5 days early, at a 0% or just fractional well reject rate compared to 2%, and hard to do statistics on safety, but they had 1 on the other project and 0 on the other project. And the only difference was that project used advanced work packaging versus not. A much larger project, 400 million Canadian, this is a mining sustainment project. They were doing basically the same scope of work every year. The first year it was terrible. The second year, same scope, they went and actually did a full AWP process with design. On that project, again, same crew, same contractor, they came on schedule and saved 10% total installed cost, and most important, whereas before they were having 1 recordable a month, they had none. The AWP process. And as a side note there, this was a reimbursable job. On that reimbursable job, that contractor in that next year was 3 times more profitable than the previous year because they were able to get better billing, they were able to utilize their equipment better. And so it was a win-win for everybody. And you talk to people up there, they fully say the only reason we got better was because we took AWP discipline. Now, we've done that across a bunch of projects now. We have 15 projects from different stages, and the left is getting started, the middle is doing pretty well, and the right's pretty mature. And without going into a lot of detail about what, where, and why, what we're seeing is that everything improves as you go up the maturity curve. And most important and revelatory for this curve is, first of all, if I was going to fake this data, I would have made it noisier. It was quite a shock to us when we saw this. But the other part is, normally when you implement a new procedure, you get worse before you get better. And we're showing even those on the left there, they're getting better as they go. So they're already seeing benefits of investment as they're getting more mature. What it basically says, you start getting better in stage 1. Stage 2 is when you really bring everybody into planning. That's where you get your big breakthroughs. And stage 3 is when you reach that level of maturity and quality that's quite important. So, as an academic, I could say, hey, I'm done. This is the best thing I've done in my career, and to a large extent it has been. I've got the solution. Well, unfortunately, this is hard to implement. We're getting the 25% productivity improvement on multiple case studies, 10% decrease in total installed cost, but it's not easy. It takes work. It's not a silver bullet. I like to call it the silver shovel. You've got to work at it. So we went from here, and I said, and some owners, by the way, are endorsing this. I think the best simple one is work packaging is just good business, and so they're starting to mandate it now. I went to this and said, okay, well, this is really about alignment. Let's look at alignment. So I took our CI team in the last 2 years. This is where Bill got to, maybe I need to change what I'm doing. We looked at alignment with the idea of improving implementation of advanced work packaging, and we just started looking in general at a few things. One of them was project execution planning. A project execution plan is something you should have out of planning documents. We found up in the middle column there is how important is it in a 1 to 10 scale, and everybody said these things are the most important things. They agreed it was pretty important. The one on the right is the frequency of how competently were these included in project execution plans. And that's a 1 to 6 scale where 1 is rare and 6 is very common. And what you see on this is that construction execution planning and, oh my gosh, number 2, project scope definition is only commonly done well. Not all the time. And then everything else is kind of frequently done well. You start saying, maybe this is part of the problem. we're not even tying our shoes very well if we're not even getting scope done all the time right in our execution planning documents. This was based on a survey of 200 people from North America who are audiences much like yourself. Then we went in and we looked at how firms did alignment in their internal procedures, and we had 13 contractors and 7 owners. On yes and no questions in that 20-page root canal we gave companies, owners averaged 67%, contractors 73%, but there's a wide range in there. Yes is good, no is bad. So we're not terrible, but it suggests there are improvements. And then when we looked in some specifics, some very startling findings. Half of the companies we looked at, and these are companies that are named companies, you would know them by name. 50% of them lack the procedure in their corporate procedures titled team building, chartering, or alignment. 80% don't consider cultural regional differences. 53% lack procedures that address continuity of key roles and project phases. 60% do not address mechanisms for communication and kickoff meeting. 60% do not get input from owner operations, procurement, or construction when developing the schedule. And that's just sort of, when you think about this as a whole, it's a pretty damning statement. It's not that we're all doing badly, but you think about it, we're not doing well. And we looked at some other data from CII that are now collecting some new benchmarking, so about 200 projects. Supplier schedules are frequently noted as a challenge in front-end planning and engineering. 73% in engineering report challenges from supplier schedules. About a third are unsatisfied with alignment during their phase. And just really telling is construction versus engineering, and engineering deliverables at the bottom of the page here. On engineering deliverables, construction said they're late 50% of the time and 75% of the time they're incomplete. And engineering said, well, we're late 40% of the time, but we're only complete 36% of the time. So our ability to be honest with ourselves is not necessarily correct either. So this is a pretty damning statement, and I kind of came back from this and said, oh boy. It's one thing if we can say AWP provides a recipe for success, but we know it's hard. And my friends at Bentley, this is borrowed from them, they say it's 10% technology and 90% sociology. It's just people issues, right? But alignment data suggests that even the base, because you have to be aligned to really do the next step, you have to be able to walk before you run. We're not doing that very well either. And at least it's an immediate recipe for improvement. You can take those little bullet points from the alignment data and say, oh, let me audit my own procedures, let me audit my own planning and see where to go. So there's, when I got to this point, I said, maybe we need to really rethink what we're doing. So to quickly conclude where we're going into the future. AWP and better execution discipline, I would say, gets us about quarter of the way there. With AWP today, you might get about 25% productivity improvement. I think if we start layering in better practices on top of that, once we get ourselves organized, we might get half again, so we get up to 50% plus. A large part of that is the BIM revolution is upon us. And so the digital track and trace, another slide from Bentley, this is some of my research, is getting better visibility in the supply chain. When that becomes real, we can really start to capitalize on manufacturing. The improvements that I've made there, we should be able to get about halfway. But I don't think it's all the way, because it's still the same system. We're optimizing a system that needs more work. And so for me, the next part of the world, and what's going to be a good thing to focus of the next part of my career, is trying to bring the revolution in materials and methods to our industry that's happened in manufacturing. And what do I think about that? Well, I think we've already seen parts of it. The radical prefabrication and standardized components. These are pictures taken from the Leadenhall building in the UK, which is in London, which was built almost entirely from prefabricated components. And just shipped it in and put it together. So, and we're seeing 3D printing. And so these are pictures of, the bottom is printing a house in China, the top is plans to 3D print a bridge in the Netherlands. Now, I think these are nice experiments. I don't think they're the future on their own, but it says it's coming. What I really think we need to do is bring the benefits of those standardization, so those are the big parts, and not use 3D printers to print a building, but use 3D printers to do all the stuff in the interstitial places in between and get rid of a lot of the waste we spend time joining, patching, cutting. Now, part of that will be driven by having the complete BIM revolution to have a purely digital track and trace all the way through, which then can drive the 3D printing and patching and robotics in the field. And so this was a screenshot from the Jetsons. So the Jetsons video was, it just pops up and it's done. And you're finished. So that's where we can go, and that's where I'm going to be going next. So what does that mean for education and CEPM? Sarah, you're in there somewhere. We're doing a good job already, I believe, of generating the next generation of leaders at the undergrad and grad level. But we're doing that for the students primarily who already have an avocation to construction. And so, as I said, I'd come back and I wouldn't be remiss if I didn't use the strategic plan here and say we are as a whole, our city's water, energy, it's our quality of life, it's our ability to move forward. We need to take what we have in our project management or design courses and our foundation courses and put some of this thinking in all of them. We need to infuse the research agenda. So it's not just Bill saying this, but when Rich thinks about what he wants to do next in indoor air quality, somewhere in there in terms of the systems he's designing, he's thinking, how can we make this faster and better and cheaper? We need industry support. And so that's for you all too. I want you guys not only to give us money and support, but really to bring this back and say, my challenge to you is let's have you guys embrace this change and say, we collectively as an industry need to get better so we can all be more productive and more profitable. And with that, let me say thank you. I'm going to move along. Yes, sir.
I hope you have some way of measuring how much of a delay or how much of a slip up or how much of a mess up is due to just getting a better product. Advanced technology in a building. No two buildings are the same. One, you may walk in and you have a light switch that turns on the light. The other, just your presence in the room may turn on the light. One may require a panel and another doesn't. So you're getting advancement there. And that factor alone is going to cause more delays and other things, but you've got to relate that to what human beings are doing too. And it's not all a human failure. You just have to have more time for things that are much better. I can remember that I used to use my telephone and I didn't see a repairman once in 10 years. Now, every month I'm calling someone either to get my Harmony remote working again or just getting my landline to work. And I spend a lot of time doing these type of things, but I'm getting much better service.
No, you're absolutely right.
You need some way to measure that though, because it's going to be naturally in there making these other things look worse.
No, you're absolutely right in that they would call it a difference in quality in a total factor productivity model. And some of the, back when I was a graduate student, I looked into some of that. And it's hard to sort those out. But the flip side of that, if you look at automobiles have all those same systems in them. They're much more complicated than they were in the post-war era. Much more reliable, better acting. Normally, you can get your Bluetooth to pair correctly. So there's a lot more in there. And so, yes, there's more in there, they cost more, but the actual cost of a car in terms of the percentage of your daily wage or your average worker wage is no more now than what it was back in the day. And so all the benefits of productivity we've seen in industry have more than made up for the increase in content. And so you're right, that does hold us back somewhat. It hurts our numbers, but I don't think it's an excuse for not trying to do much better.
It may not be an excuse, but it's certainly one of the causes.
I wouldn't disagree. It's part of that. Teasing it out is difficult, but the aggregate is pretty bad no matter how you want to paint it.
But the process still applies. The process of more collaborative early planning would solve a complex system just as well as with a simple system.
Yeah, no, I agree.
Process approach could be applied. Seems like a lot of this ties back to what Deming started when he went over to the Japanese and began to talk to them about collaboration of teams and early thinking. You call it AWP, but other names.
Well, I think that what I would learn from the Deming and Duran, the quality people, is it's not the person, it's the system, right? It's people who are going to perform as well as they can in the system. You give them, and the system is poor. And a case in point, we did a case study in my class this semester for a mechanical contractor, a very progressive mechanical contractor in Austin on the EERC building. But I was talking to the president there, and he said, in his opinion, BIM has actually made things worse rather than better, because it's actually increased, because of the ability to move things around virtually, has made it even easier for the engineers not to do good detailing. And so therefore, as a mechanical contractor, I'm spending more time than ever to do the final design and detailing, despite the fact we have BIM. And so in the system we're working in, the broken system, it's not, rather than utilizing that to get better, we're actually, it's an excuse to get worse and pass things back off down into the supply chain. There was a comment.
Sounds like AutoCAD.
I have a question.
Sure.
Sound like all kids.
My company, we produce, I'm an engineer, structural engineer, we produce work packs with large projects. I don't understand what you mean by advanced though. Can you explain what's the difference between an advanced work pack and a regular work pack?
So an advanced work packaging is more of a philosophy for how you organize the project. And so what that really comes to is, in early planning, normally at a feed stages or the early part of design, you have a constructability review and you have some initial assessments of schedule, and you throw things over a wall, detailed design, and you get started. What's really new in AWP is, out of that feed stage, you've done more construction execution planning, and you've agreed on a work package plan from the contractor and the engineer that works together, that agrees to those deliverables. And so I've got friends at Fluor that would say, I'm a structural engineer at Fluor, hey, I'm happy to deliver that way to you, but nobody usually tells me until I've already started my design, and now it's kind of late for me to do that. So it's doing that earlier on. And there's some more detail. I don't want to go into every little micro bit of that, but that's the sense of it, is really the early planning to get it done. And every time we really looked at that, we say we do it, we just don't do it well enough until you really get into it. And a lot of that is not your fault as an engineer, it's the owner's fault for not bringing the people in early on and making the commitments to design early on. The great dirty little secret of advanced work packaging is that the owner has to be on board and get the right people in the room early to make decisions, so that 6 months into construction, the O&M people don't come on and say, hey, we need to change everything.
Yeah, we see that all the time. I'm working front-end project right now. My fingers crossed it keeps going, but where contractors, fabricators, whatnot, unless they're getting money, they don't want to talk to us. Right?
Yep, exactly. And so that's part of the owner's job then, is to bring those people in the room and create the opportunity for it to happen. So the owner has to not do more planning or pay for more planning, they have to pay for more of it up front. And don't expect the project to get better if they don't.
What most likely will happen is it probably will not ever happen. Because at this point in time, this is a good topic, and this is very timely, I think, because like you showed in your graph, the cost for a barrel went 4 times in these last 40, 50 years. I have some projects that I benchmark, I leverage out 10 years before. My cost right now is almost double, right? So what it means to us is that, okay, we have pretty much deal with the inefficiencies, the low productivity, and everything else by putting more money, because the business is still good, our sensitivity analysis still shows that we are making money. But we are coming to a point in which we are not making money. And therefore, if I'm not breaking even in the next 8, 10 years, I'm not doing that project anymore. And that's where we are, especially here in the Gulf, because our market intelligence and everything else that tells what projects are going, what are the ones coming, what are the average, what is the size of the projects. We don't see anything getting better, but just getting worse.
Something
So,
may have happened this morning.
Yeah.
Saudi Arabia just changed its oil minister.
actually, I was in Saudi Arabia for the last 5 years, and I met that man. I mean, he was the CEO of Aramco, went to be the health minister, now he's the new mineral and oil minister. Yeah, Saudi Arabia is changing all.
Could change overnight,
Privatized Saudi Aramco, I heard, so.
except he's an Aggie.
He's an addict.
Well, things may change then. If you guys want to volunteer, but, Rich, how are we doing on time? I know I can stay for a few minutes to,
Time for one or two more questions.
I can stay for a few minutes for those who want to beat me up, or.
One question, sorry for that. Have you actually looked at Model A type of project industry that Model by Model A is telling you, we use resources within the company, pretty much from FPL all the way to the end of the project. Because in some instances, what we do is so highly protected in terms of the intellectual property that we don't go anywhere with our engineering or even management of construction. We just sanitize our scope and we just send it over. So with that kind of project, you have everything that you said that it doesn't happen in that one, check mark. We do it all.
And if you can do that well, and you can bring the expertise on board, that's wonderful. And one of the big problems is when owners after the 70s started getting rid of their in-house expertise, a lot of these problems started to get worse because there wasn't a good advocate in the owner. And so there's a lot of thought right now is how big should that owner staff be to work on it. And I don't think there's an answer to it. I think has to be project specific. If it's a proprietary technology, it makes sense to do that. I think the key thing is to make sure that planning and execution discipline happens so that when you go, you're going with that plan in mind. And if you deviate from it, you deviate with cause. As a friend of mine said, this project's going great. The last thing it needs is a good idea.
A good example of that was John Brown with BP, who about 1990, 1995, fired the whole engineering department at Sunbury for British Petroleum. Said, we can get the engineering we need from contractors. We don't need our internal engineers. And look what happened to BP a little bit later after that. So he didn't want to pay the money for it.
I'll turn that over to Rich to close this out. So.
Thank you, Bill.